video, what we're going to do is we're going to try and find the greatest common factors and answer the question, how do you factor polynomials by GCF, or the greatest common factor? Let's start by looking at finding the factors of the number 60. 60 is 2 times 30, and 30 is 2 times 15, and 15 is 3 times 5. So if I bring down, I can see that the factors of 60 are 2 times 2 times 3 times 5, just to remind us of exactly what factoring is. Now, if I was trying to find the factors between two numbers, such as 24 and 60, what I would do is I would line up my two numbers and I would factor them. 24 is 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. Now 60 is 2 times 30, and 2 times 15, and 3 times 5. I like to line up my numbers when I'm doing this. That way I can look at this and say that my greatest common factor, or GCF, is going to be 2 times 2 times 3. So I see that my greatest common factor is going to be 12. That's just of two numbers. What if I had to find the greatest common factor between two numbers with variables, like 3x squared and 6x? Then I would list my factors for those as well. 3x squared would give me 3 times x, and 6x would give me 2 times 3 times x. So again, I can circle what we have in common and find that my GCF, or my greatest common factor, is 3x. Now, looking at how this is working, if I was to have something that looked a little more sophisticated, like 7 times the difference of x and 3 minus 2x times the difference of x and 3, when I'm looking at this, it seems to be much more difficult in how it's set up. But this is no different than if I had a times c minus a times b. I could take out those a's and be left with a c minus b. So what I'm going to do is I'm going to bring down that x minus 3 that they both have in common. Having brought those out, I'm going to be left with times a 7 minus 2x. So all I'm doing is taking that factoring one little step farther. To take it one step even farther, if I had a polynomial like 3x cubed minus 15x squared minus 2x plus 10, then what I could do is I could look at my left two numbers and I could ask, what do these two have in common? And I see that they both have a 3x squared in common. Now, what's left over out of that 3x squared or 3x cubed when I take 3x squared out? I'm left with an x. And what's left over out of that negative 15x squared when I take out a 3x squared? Well, I have a negative 5. So I have x minus 5 left inside parentheses and a 3x squared on the outside of the parentheses. Similarly, on the right two, if I look at those, I always take the lead sign. So I'm going to take out a negative. And 2x and 10 both have a 2 in common. So what I'm going to do is I'm going to say negative 2x divided by 2 is going to give me an x. And 10 divided by a negative 2 is going to give me a negative 5. And at this point, what I'm able to see is that this now looks very similar to the problem above. I can bring down my x minus 5 in its set of parentheses, and setting up an empty set of parentheses, I see that I have the 3x squared from the left that I'll bring down, and I see that I have that minus 2 that I'll bring down. And so that this is a fully factored form of the problem above. So all we've done here is group them as pairs. If this video has been helpful, please like or share. And if you have any questions or comments, they go below.